This video is a summary of current atomic theory and the contributions that led to that along the way. So this is not all of the work that they went into doing, but this is the things that resulted and that transcended time and stayed as part of modern atomic theory. So it began the middle of the 5th century with Democritus, and he was a Greek philosopher, and he came up with the idea that all matter was made of little tiny particles that he called atoms, and he thought that atoms had a specific type of structure, that each atom was different in some way, and so he was really onto a fundamental principle of current modern atomic theory, and that is that matter is made of particles, and that each type of matter has a different type of particle. So John Dalton was the next person to come along after a long period of time where Democritus's contributions were ignored, and so Dalton comes along, and he began to observe how chemicals combined, and so he came up with a model of atomic theory, and from his model the following things came out and have stuck in. One, all elements are composed of atoms, just like Democritus said. All elements are composed of atoms, so each element has its own specific type of atom, and so that was very much like what Democritus said. Dalton went on to say that compounds are types of matter that are made up of multiple elements, and he went on to also observe that when compounds are formed, it's always in a fixed ratio of the atoms. So he was able to really lay some very long enduring concepts about atomic theory down, and they have stayed around. After Dalton, the next scientist to come along who contributed to our current theory was Thomson, and Thomson was the first to identify that atoms themselves are made of smaller particles. And he discovered that there were charges involved, and he did some work with gases, and so he was able to determine that the atom itself is made of smaller particles and identify the positive and negative charge within the atom. The next guy along who added to that was Rutherford. Rutherford was able to determine that the nucleus is surrounded by the electrons. So he was able to kind of give a picture to the structure of the atom. And in the Rutherford model, all of the protons and neutrons are densely connected into a central nucleus, and around the nucleus, Rutherford said the electrons were positioned. So after Rutherford, Niels Bohr came along, and he began to extend Rutherford's model by identifying a little bit more about where the electrons were located. And Bohr identified locations in the atom that he called orbitals, and that the electrons would locate themselves in these orbitals based on the amount of energy each electron had. So electrons, in Bohr's model, electrons must orbit the nucleus in one of several fixed orbits, and each orbit represents a specific energy level. And the first orbital represents the lowest energy level, and then the second orbital is the next highest, and so on and so on. And so the orbitals served kind of as locations and energy levels both. And then the modern theory is the electron cloud model, and in that theory they have gone to say the location of the electrons cannot exactly be pinpointed. Although they are in orbitals, All we can say is that they're somewhere in the space of the orbital, but not exactly where. We can know that they're located there, but not pinpoint exactly where they're located. All of these things combine to give us this modern model of the atom. And so in that modern model, to quickly reiterate, so we have every element has its own unique atom, and the configuration of that atom is specific to each element. We will learn later that the number of protons identifies which element it is. So each element has an atom with a different number of protons. The protons and the neutrons are densely clustered in the center of the atom, and the space around the atom is filled with the electrons, and the electrons locate themselves in various orbitals, each orbital having a specific and different energy level. The first orbitals have the lowest energy level, and the further out that you go, the higher orbitals that you reach, the higher the energy level. So that's the quick picture of the modern model of the atom.